Hello everyone. In this video, I will be talking about collisions. Introduction. Collision between two or more particles is the interaction for a short interval of time during which they apply strong forces on each other. Examples of collisions include while in the game of carom, we use the striker to strike a carom and put it in the pocket. Similarly, in the game of pool or billiards, we use a stick to hit a white ball and which in turn collides with other balls to land in the hole. Another example of collision is a road accident in which two cars going head to head hit each other. Another example of planetary nature, that is a meteorite hitting a planet. That's also an example of a collision. So in this video, I will be discussing about collision. We shall analyze the whole process of collision and derive appropriate relations between each of the physical quantities involved. So the law of momentum and energy conservation can be applied to the study of process of collision. This is the main laws which are regarded in deriving the relationship between various physical quantities involved in the collision. There are mainly two kinds of collision, namely elastic and inelastic collision. Collision in real world lie between perfectly elastic and perfectly inelastic collision. That is inelastic collisions. In case of inelastic collisions, the momentum is conserved while the kinetic energy is not conserved. While in the case of perfectly elastic collision, the kinetic energy as well as momentum is conserved. In case of perfectly inelastic collision, when two bodies collide, two bodies fuse together and move together. As in the example in which a meteorite hits Earth. In elastic collision, since both kinetic energy and momentum is conserved, the bodies involved in the collision come back to their original state. While in case of inelastic collision, some energy is lost in the form of sound or as heat, and it causes deformation of the bodies as well. For example, in the case of a road accident, when two cars hit each other, some energy is produced in the form of sound, and deformation of the body of the car also can occur. Now, we can consider masses of m1 and m2. m2 is stationary at first, while m1 is moving with a velocity of v1I. This mass m1 moving with a velocity of v1I hits on m2, and after collision, m1 moves with a velocity of v1f at an angle of theta1, while m2 moves at a speed of v2f after collision at an angle of theta2. The momentum delta p1 is equal to f12 into delta t, where f12 is the force which is exerted by the mass m1 on m2, while the momentum p2 is given by f21 into delta t, where f21 is the force exerted by the mass m2 on m1. Now from Newton's third law, we have F12 is equal to minus F2. Hence, we can say that the sum of this very small momentum, that is delta P1 plus delta P2 is equal to 0, or it's a constant, or we can say that momentum is conserved. The total momentum of the isolated system is conserved. Now collisions in one dimension. Completely inelastic collision. In this case, theta 1 is equal to theta 2 is equal to 0, and m1 v1 I is equal to m1 plus m2 into vf. From this, we can derive the equation for vf. Vf is equal to m1 into v1 I by m1 plus m2. Now, loss in kinetic energy. Since this is a inelastic collision, delta k is equal to half mv1 I square minus half into m1 plus m2 vf square. Since both masses now move together, this is a completely inelastic collision, which gives delta k is equal to half m1 m2 by m1 m2 into v1 I the whole square. Now elastic collision. In case of elastic collision, we have got two equations. First is the case of conservation of momentum, that is m1 v1 I is equal to m1 v1 f plus m2 v2 f, and the second is the case of conservation of kinetic energy, that is half mv1 square is equal to half m1 v1 f square plus m2 v2 f square. In this, the term half 1 by 2 is cancelled out. Now from equation 1 and 2, we can prove that v2f, which is the final velocity of the mass m2, is equal to v1I plus v1f. Now substituting this in the equation 1, we get v2f is equal to 2m1 v1I by m1 plus m2, and v1f is equal to m1 minus m2 by m1 plus m2 into v1I. That is, if the initial velocity of mass m1 and the masses m1 and m2 are given, we can find the final velocity after collision. Now collisions in two dimensions. We have got two equations. That is, first for the conservation of momentum, m1 v1 I is equal to m1 v1 f into cos theta 1 plus m2 v2 f into cos theta 2. This is in the case of the horizontal component. In the case of vertical component, 0 is equal to m1 v1 f into sin theta 1 plus m2 v2 f into sin theta 2. For elastic collision, and when theta 1 is equal to theta 2 is equal to 0, we get half mv1 v1 I square is equal to half v1 f square plus half m2 v2 f square. Using these equations, we can find the v1f and v2f. If theta 1, theta 2 is given, as well as m1, m2 and v1f is given. So this is the end of this video. In this video, I have discussed the concept of collisions and have applied the laws of conservation of momentum and conservation of kinetic energy to derive certain relations between the terms involved. If you have got any doubt in any of the concept discussed in this video, please comment in the section below this video. Thank you.